In this video 1-7 we will be looking at the distributive property. By the end of the video and the work time in class you should be able to say I can use the distributive property. So what is this property all about? You're going to let A, B, and C be real numbers. A times in parentheses B plus C is the same as A times B plus A times C. And so what happens, I'm going to replace these letters with numbers here. I'm just going to pick three real numbers, let's say 4, and let's see, 20, and 20 plus 6. Okay. Now what happens here is we take the 4 and we distribute the 4 to both of the terms inside the parentheses. So you can see as I distributed it kind of made this form an image that looks somewhat like a rainbow, which is something you'll hear me, that term make a rainbow, you'll hear me use throughout the school year. So I'm distributing the 4 to the 20 and the 4 to the 6. So I'm doing 4 times 20 plus, because there's a plus sign right here, plus 4 times 6. We could continue simplifying. We're just going to leave it like that for now to show what the distributive property does. Same works if I have a real number on the outside of the parentheses to the right. You're distributing the A to the B and the C this direction, where up here we did it from here, from the left. So now we're just doing it from the right. So if I set up a problem, I'll just use the same values, 20 plus 6, but had the 4 over here. I'm distributing, making that rainbow image. That would be the 20 times 4, or 4 times 20, because commutative property, plus 6 times 4. The same works for subtraction. You distribute the A to the B and the A to the C again. However, on this one, so I'll use three different real numbers, 7 times in parentheses 30 minus 2. I'm distributing that 7, but when I write it out as I simplify, I have 7 times 30 minus 7 times 2. And the same works if that A, that real number's to the right, and we distribute to the B and C, and we're subtracting. So if I had 30 minus 2 with the 7 here, I'm distributing the 7. So I have 7 times 30, or if I'm consistent with how I wrote it above, 30 times 7, however commutative, that order doesn't matter, 2 times 7. So that's representing the distributive property. So we'll use the distributive property here in some examples. 4 times the quantity x plus 5. You distribute the 4 to the x and 5, so you have 4 times x, which you write 4x, and then 4 times 5, and we're adding because of the addition symbol here, and 4 times 5 gives you 20. This is simplified all the way. We don't know what x is, so we're good to go. Here in the distribution, I'm distributing the negative 6. Negative 6 times 4b is going to give us a negative 24b, using our rules with multiplication that a negative times a positive is a negative. Now in this one, I'm going to look at this as negative 6. Now this 1 right here, that is really a negative 1 if that minus sign is in front of it. And so negative 6 times negative 1 is really giving us a positive 6. Now if you didn't look at it like that and you said, well, I'm going to keep it as a minus sign and look at it as negative 1 or negative 6 times 1, which is negative 6. Well, we know that a minus negative is really addition, so this is addition right here. So what I want you to do is whenever you see you're distributing and you have a minus sign in front of a number, this right here is a negative 1 to give us a positive 6 when we do negative 6 times negative 1. For number 3, we have 3x plus 1 all divided by 5. So what I'm going to do is pretend I'm going to put this in parentheses, and I'm going to multiply that by 1. Multiplying it by 1 keeps its identity. And I'm going to look at this as 1/5, because dividing by 5 is the same as multiplying by 1/5, 3x plus 1. So instead of dividing by the 5, I'm going to take this 1/5, multiply it by 1/5. Distribute the 1/5. 1/5 times 3x gives you 3x over 5 plus, as there's a plus sign right here, 1/5 times 1, which gives you 1/5. Now that was using the distributive property to simplify that expression. You could have also just taken both terms over here. So I'm going to erase this. If I would have just taken 3x divided by 5, look what I get, and 1 divided by 5, which is 1/5. But what I did is used that distribution property to get our simplified form. Now in this one I have the opposite of the quantity, 3m minus 4n. Now if you don't see a number right here, this is a 1. We just don't write it. So really this is -1. So we're distributing a -1 to 3m, and then -1, remember this is -4n. So a -1 times 3m is going to give us a -3m, and -1 times -4n is going to give us a positive 4n. Deli sandwiches cost $3.95 each. What is the total cost of 6 sandwiches? And use some mental math on this. So I'll show you with mental math. See, essentially we're doing 6 times 1 sandwich, which is $3.95. And so if I use the distributive property to use the mental math, this would be the same as saying, well, 6 times $4 minus 5 cents, which is $3.95. So if I were to distribute, using the distributive property, 24 then minus 6 nickels, which I know is 30 cents, $24 minus 30 cents gives me $23.70. So that's solving the problem using the distributive property. We didn't need to do that, but that would be demonstrating that property with a problem similar to that. What is a term? A term is any number, a variable, or the product of numbers and one or more variables. So we're looking at any number is a term, just a number, a variable alone, or for multiplying or dividing, since it's the opposite of multiplying. If you're multiplying or dividing real numbers, that's a term as well. We're going to be looking a lot at terms here soon as we get more into the algebra content. A constant is a term with no variable. A term with no variable, so you just have numbers. A coefficient is a numerical factor of a term. So if we're looking at 6a squared minus 5ab plus 3b minus 12, we have 4 terms here. Here's a term. 6a squared is a term because it's a product of 6 and a squared. Negative, remember that minus sign's in front. Negative 5ab is a term because it's one product. We're multiplying negative 5 to a and b. So that's one product, so that's a term. That's a positive 3b is another term, and then negative 12 is our 4th term. So negative 12 here is a term with no variable. Negative 12, it's an integer, it's a real number. There's no variable, it's multiplied by. That is called a constant. And the coefficients would be, so I'm going to label this here, this would be a constant. So we've got our term with no variable. And then we have our coefficients, and the coefficient, I'm going to label that, so this right here, our coefficients, I'll use a different color, are the numerical factors of a term. So the 6 is a coefficient. the -5 is a coefficient, and the 3 is a coefficient. You're multiplying those numbers to the variables. Those are coefficients. We're going to be looking at like terms. Like terms have to have same variable factors. They have to have the same variable and the same power. So what are like terms looking like? Here are some examples of some different terms, and we're going to figure out which ones are like and which ones are not like terms. Well, 7a and -3a. We look, do they have the same variable factors? They both have an a, and that a is raised to the first power. You just don't see the first power. And since they both have an a to the first power, yes, they are like terms. In the next one below that, we have an AB and we have an A. Since there's a B here, they are not like terms. They both have to have A and B. 4x squared and 12x squared. We look at the variable factors. They both have an x and they're squared. So they are like terms. We have xy squared and x squared y. We have a 1 here and a 1 here. Now the x is to the first power in one, but to the second power in the other, and vice versa with the y. So they are not like terms. They have to have the same variable raised to the same exponent. When you have like terms, then you can combine like terms. When we combine in math, that's when we're adding and subtracting. So we see here we have x squared in both of these terms. We have two terms. They have an x squared. So we look at the coefficients. We have a 5 and 7, and it's plus. So 5 plus 7 then gives us 12x squared. So if we have 5x squareds and we add 7x squareds, we're left with 12x squareds. Now in number 6, we have 1, 2, 3, 4, 5 terms. And so we have to match up our like terms. Well, I have a 7x, and that's a like term with a -3x. Notice I pointed out it's a -3x, that minus sign in front. 2y, that's positive. I don't see a like term because there isn't another term up there with a y. I have -5, and that would be a like term with 1 because real numbers, constants, we can add or subtract them. So we're going to combine the blues. 7x minus 3x gives us 4x. The green, we have nothing to combine it with. Now I'm putting plus 2y because there was a plus in front of it in the previous expression. We're just simplifying here. And then our constants, we have -5 plus 1, which gives us -4. So we write -4 to show -4. If you put plus -4, that'd be the same thing. It looks more simplified here. So we went from 5 terms down to 3 terms. We just simplified that expression, that algebraic expression, by combining like terms. Can you say, I can use the distributive property? Write your summary and reflection and be prepared with questions for in class.